Ziegler. I'm really happy to be here today with all of you. Part of me feels like they did a little joke by putting me in here because so much of my research is so different than yours, but I love getting to hear it. But earlier today I thought, you know what, I'm not going to do this and I'm just going to give everyone the talk outside because that would really make sense with what my talk is. But now I'm like, it's a little wet and I think we're not going to do that, and I prepared the presentation, so I will. But forgive me for having it not be a little bit different from what we've seen already today. So I get to share with you something I'm very passionate about. I work in Madison, Wisconsin in the United States, and I work in a school that has kindergarten through graduate and postgraduate students. So we have a lab school on site, which is great in many ways, but car line pickup can be really problematic at certain times, but other than that, it really benefits our student teachers who I get to work with. But I also am employed at the elementary school where I help as a learning resource coordinator. So I really get the best job because I get to see it coming through, from practice, from theory rather, to practice. And I see a lot of really good things, but I see some, like I've heard today from many of you, some areas where there's room for growth. There's room for growth. So I'll leave it at that. This talk is coupled with the research I wrote on it, which goes into a much more lengthy literature review, which I will be skipping a little bit over. I hope that's okay. And although this is really focused in science education, I really believe that it's at the heart of all education. But I'm a science geek, so I'm a little bit biased in that. Because at the heart of every educator is someone who believes in a better future. Otherwise, why would we be doing this? And I think that really means supporting young people of any young age to flourish, to make and understand big decisions and consider a world that's larger than themselves. But as you know, if you're a teacher or a parent or anyone, you know you can't just say, make good choices, and that follows through with action. Common sense tells us we need to show or lead by example. So I conform to this idea that David Sobel said a lot better almost 40 years ago, but I think it's still true, that you can't get students intrinsically motivated to be stewards of any landscape without first allowing them to really know and love that landscape. And that's a piece that in the US has really been missing. Quite simply, it can and should be a daily part of curriculum at every age. To add to what he wrote, I also argue that creating environmental stewards, or rather students that feel very responsible for and acting in ways to support their environment, local and beyond, comes from a collaboration of these three things: outdoor recreation, traditional ecological knowledge, which I'll talk a little bit more about, and long-term student-driven research projects where student choice and high-level science are really emphasized. So during this hopefully brief talk, cut me off if I go overboard, I'm hoping to mention a couple bits of those literature that I think are particularly profound. I want to share with you a case study of what I get to see on my campus, and then ask you to consider how, even though there might be a big jump, how this could apply to your future positions in education. Because of the international nature of this conference, I feel like I need to just briefly mention what's going on in the US with science ed. But this could be its own talk, conference, support group itself, because it's been a weird 80 years. So basically, after the space race and realizing we didn't do so well, our Congress finally invested some money in science education that had not happened ever before. As a result, lots of acts and committees and helpful things have happened that instead of emphasizing science education, emphasized math, literacy, and therefore assessments. And that was the only way to show knowledge, but you all know that that's not best practice. But that was what our standards had dictated. So in about 2011, a group of scientists, great to get scientists involved, and professional educators in the sciences and just pedagogy got together and developed a new framework for K-12 science education. Basically, what should you be able to do before you graduate high school, and then beyond in post-secondary. We had new standards formed. They're now over 10 years old. We still call them the new standards. And they were, the big change was moving from a list of stuff you need to know, like the mitochondria is the powerhouse of the cell, A lot of people still remember that, but don't know what that means. Instead having it be really performance-based. You need to be able to solve problems. I kept thinking of Jan's talk today about challenge-based learning, and that really, I know it meant in a college setting, but I really can see it working in so many other settings for that reason. So that's kind of where we are. We went all assessments, and now we're going, whoa, maybe that didn't really work. And now the students that we're getting at truly every level are aware of what's going on with climate change and concerned about it, misplaced in some ways, and then we're scaring the crap out of them is what we're doing, honestly. So all that led to, as Richard Love describes, some really long-lasting effects because of this focus on standards and assessments and a really radical moving away from place-based education. Nature deficit disorder, if you're not familiar with it, was a term coined in 2005 and describes a disorder that plagues children and adults, and it's characterized by a lack of knowledge about the natural world and just outdoor playtime. He describes that it results in, not just him, many researchers, which I cite, describe that it involves decrease in attention span, a higher risk for health problems, decrease in problem-solving skills, higher levels of depression and anxiety, a decrease in confidence, and an increase in anxiety. Just a few things. And it really comes from a lack of time in the outdoors. So the nice part about this is the solution feels really easy from my perspective, but I did teach science for 10 years, so it was a logical connection. Another set of research I wanted to mention came from a researcher out of Switzerland who explored the connection between knowledge and environmental issues. And in summary, it was a great study, a long study, but they found that there's basically little connection to knowledge and action on the subject, which was like a knife in my heart at first, because you want to believe the more you learn about it, the more you are able to act. But what he found that was missing is that environmental behavior really is mostly related to your environmental experiences. And that, to me, felt very profound. Finding a way to incorporate education into nature experiences could potentially result in greater environmental behavior. In other words, there's no replacement for outdoor experiences when you're fostering environmental stewardship. So why not combine both rigorous student-driven research and outdoor recreation using place-based education? I go into much greater detail about traditional ecological knowledge in my paper, but to keep it brief, there's no way to do place-based education without acknowledging and exploring the traditional ecological knowledge of the place, because science has been happening on almost every continent for millennia from indigenous people, and if we don't acknowledge that, particularly in the US, it's quite problematic right now, then we're doing a complete disservice to our students and the future. This science, traditional ecological knowledge or indigenous science, is rich, it's valuable, it's misunderstood, and it contains infinitely more data points than Western science could even imagine given its mere 100-year history. Both sciences need to exist concurrently, not apart from one another, so inviting indigenous people, scientists, and communities to share is really key to the longevity of this research. So this case study explores a multi-year project from Edgewood Campus School, which is a private school that sits on the edge of an urban lake in Madison, Wisconsin, which is really known for its lake community. We've got a string of 5 lakes that are all connected except for Lake Wingara by a river. It's a lake vibe. It's very much key to the community. There's also a number of different private institutions that sit on the lake, including the schools, the golf courses, arboretum, etc. So the goal of this program was really just to answer for the students, what's the health of the lake? How can we ask a question about the health of the lake? And then what are we going to do about it? This is potentially the most studied lake in the world. There's an argument between another one, and it's like, I don't know how you can really quantify it. But 3 big goals, and that was to address the science standards, to immerse of our state, immerse them in place-based education, that's one of my students standing on the frozen lake, and then to expose them and introduce them to some indigenous science involving people from the community. So these are the major steps that were involved, and I'll go through each of them, hopefully, briefly. The first thing we needed to do was engage with the story of the area. We invited indigenous tribal members. We heard about them through literature, podcasts, historical documents, and like I said, guest lectures to understand the significance of that area in a community where a majority of my students were of non-indigenous descent. including myself. And here you can see the students learning from a University of Wisconsin graduate student about the native fish after they caught the fish and played with them and named them and screamed about it and all sorts of things. So learning about the importance to their diet and historically the significance of that area. Next, students pose their own research questions about the health of the lake that they designed their research project on, which is part of a much longer data set we've got going back almost long from middle school, 8 years, which we're quite proud of, almost 10 years. So they studied things like dissolved oxygen, pH, conductivity, carbon dioxide, nutrient loads, macroinvertebrates, so little critters, zooplankton, fish, birds, plant life. They got to choose. And then they compared these values based on their scientific method to different locations within the lake. It's the only spring-fed lake in the area, so that's interesting, or to other lakes in the community or beyond. Then we carried out the data collection. It was on foot, it was by kayak, it was walking on the ice. And a lot of the pictures I'm sharing were actually during the pandemic when our school was closed. So we got special permission to have students come and meet outside, hence all of the masking that you see here, but they don't wear masks now unless they want to. Then students gathered their research and compared their existing data to their own data. They took on the role of policy informers and shared their findings in what we call the State of the Lakes Address. A lot of communities do this, where they come a lot like this, they dress up, and they share what they have found to be an issue based on their research findings. And we had a lot of interesting and important people actually attend those, which was really fun for them. Then they determined civic action projects to take action. So based on what you saw, you think we saw really high nutrient levels, what should we do about it? And this is what was really exciting for me to see. We had kids and families volunteering, seeking out elderly neighbors and making sure that before a rainstorm, they were removing all the leaves from the gutter so that phosphorus was not being leached into the lake, or they were hosting information sessions at their local churches to talk about different issues with the lake. And given this is a lake community, everybody's on a boat, but not a lot of people are thinking about this particular research. I can't emphasize this enough, but this slide in itself would have been like kind of a boring talk. But this is the key, I think, to why so many students remember and perform so well on assessments, and it was fun. They got to go outside and use gas-powered ice augers, right? We fell in the lake. We found really slimy things. We met people we had never met before. Our school is right on the lake, but only a handful of them had ever been on lake water, and almost none had been on frozen ice, a frozen lake. So that fun factor is something that we can do and we should do regularly. So measuring outcomes was challenging, because that really wasn't my goal at the start of this. So I've taken students' words, and I really want us to consider that as real data as well, because what I did learn from this is that student interest was sparked. I still get personal letters from students about it, or their parents about it. Their curiosity was sparked, their interest was sparked, and that to me means we need to find more ways to have students have fun learning, like escape rooms, or mapping each other's faces to find, that's fun. It should be fun. Learning is meant to be fun, but also make the world a better place. I didn't edit any of these for spelling, so I wasn't grading that, but. So just as conversations between Western and non-Indigenous science encourage us to look at data that's not qualitative or quantitative, we also need to look to our students for indicators of passion and joy when we measure the success in schools. So I want to thank the following individuals and organizations for support with materials, with information, guest speakers, grants, to support professional development, and a lot of the people in my community who did a lot of this work. It doesn't take one person, and that's, I think, a trend that we're continuing to hear throughout today, is that you need to involve the community in what you're doing. And I want to invite you to maybe consider some of the first times you felt particular joy in the outdoors, and how that, or maybe you have yet to, in which case less so, and how that might have influenced you in your attitude towards civic engagement or learning or what you are doing now. I really look forward to a future where students consider their teacher not a keeper of the knowledge, but instead someone to explore with and explore alongside, because I think that gives them agency, and together we can look to the landscape to really educate and inform us. And that's all.
Production values for your slides, top notch. Well done. Any questions?